Hi, this is Najmusimab, and you are watching GetWays Solution. And today is day 3 of 30-day coding challenge. And in this, I'm going to solve a lead code question. And question goes like this: palindrome linked list given ahead of single linked list, return true if palindrome, else false. So I will copy this example and we'll try to understand the question in lead in our whiteboard. And whiteboard is opening. Oh yeah. So now whiteboard is open. Now I will delete the previous questions thing. I'll paste the new value and here go white color. And yeah, suppose given linked list is 12221. So this is a palindrome. So we have to return true if this case, if we have this case. So how we are going to solve this? So what we are going to do is we are going to take this linked list 122 and 1, and we are going to middle of it. So middle is basically here it is even. So so middle will be this one or this one, any of this. So we will compare these two and we will compare these two. If these two are equal, we didn't find any element which is not equal, then we will return true, means it is palindrome. And how we are going to do this? We are going to do this with the help of two pointer method. And two pointer method, how we will use, I will cover everything in detail as always. So we have one, two, two, and one. So here this is the linked list. So we will introduce two pointer. Here both the pointer initially will point. Suppose one slow pointer and one fast pointer. Both of the pointer will initially point to the head which is at 1. So now the fast pointer will move at twice speed. So in first iteration, fast pointer will reach here and slow pointer will take one step, it will reach here. In second iteration, fast pointer will hit null because fast dot next is null, means iteration over fast is at null. Okay, fast is null and slow will be here. Okay. So what we are going to do, slow now pointing to this particular position. Now what we are going to do, from here we have slow and fast is null. So we will take slow, and from here to here, this part we are going to reverse. So it will be like 1, 2, 1, and then 2. From the here we are going to reverse slow. So if we will reverse slow, it will become like this 1 2. And how to reverse, I already have covered this, like how to reverse a linked list. We already have done that video. You can see in the I button. When you click, you will get the video. I will add in description also uh, for that video reversing a linked list. So here now as will point. So now what we will do, we will, since f is null, now we will assign head to the f. So now f is here. So now we will start compare. So if f dot val or s dot val, value of this fast node and slow node, we will compare. If matched, then we will go ahead. If didn't match, then we will return false, means this is not palindrome. If it matched, then we will go to the next value. So f dot next. Now f is here and s will come here. And now in next point, s will reach to the null, means we will end our operation. And if we didn't find any unmatched value, means we will return true, means it is palindrome. So hopefully you got all the concept. First we will introduce two pointer, one with fast speed, one with slow speed. This is the way of finding middle element. We use two pointer. So hopefully you got, I am explaining more and more. I don't know, like hopefully you got, like from here we will reverse the list, and first half will be as it is, second half will get reversed, and in reversed, our first pointer will be slow, and from slow we will start comparing with the initial nodes. Initial node, which is basically head, and we will assign head to fast, and everything will work fine. And now we will see, I think when I code now, you will get it perfectly. So let's jump into the code, and here we go. So here I have given boundary condition already, and I have written logic for reversing linked list, and which is quite easy. Like you have to just change the node from next to previous, and that will work. And the head you need to point to the null, and yeah, the null which you are pointing earlier, it will become head. So which is quite easy, and I have covered this concept all separately, so you can go there and watch. It is very easy. And reversing linked list is like kind of classic problem, and finding middle of linked list is also a classic problem. So this is a combination of two classic problem. So here what we are going to do, we are going to introduce a node, let's call it as slow, and I'm going to initialize it with head. And similarly, we are going to do one more pointer, which is known as fast pointer, and we will call it as initialize it with head only. Both are initialized, both are starting at same position, but one will run with the double speed. So the one which is going with double speed will finish first, so we need to check null condition for that only. So fast equals to null, and then fast dot next equal to null, because we are going to move fast with twice speed. So there might be possibilities that in next step fast become null. So to avoid null pointer exception, we need to give this condition fast dot next equals to null. So now what we are going to do, we are going to update both slow and fast. Fast equals to fast dot next of next, and slow will be slow dot next, one step at a time. For slow, one step at a time. For fast, two step at a time. So now our fast will, when our fast will reach null, our slow will be at the mid. And now we want to reverse the another half, means the end half. So we will reverse. So for reversing, we already have written a method, that is reverse list. So in this we will pass slow, and now we will assign fast head, so that we can compare easily. So now we will write a condition while, since slow is at middle, so slow will reach null first, because fast is at the first position right now, because we have assigned it to head, and now fast is no more fast. Fast and slow both will move with same speed. So fast slow not equals to null, then in that case we are going to check first the condition, that if slow dot val not equals to fast dot val, in that condition we will return simply false, because we found a match, we found a mismatch, means we found a mismatch means no more palindrome. If this is not the case, then we will move slow dot next, and we will move fast also. Fast equals to fast dot next. And if after completing this whole loop we didn't find any mismatch, then it's a palindrome. So we will return true. Hopefully everything will work fine. Run code. True, true. Submit code. Yeah, solution got accepted, and we satisfied the condition. We have done could do it in O of n time and O of 1 space complexity. So we haven't used extra space. And if you see, we have used a while loop, but both two while loop, but both are independent, not nested. So that means that O of n is the time complexity, and we don't used any extra space. So it is O of 1. We have used some space, and those are for pointers. So this is 1 1 1, so that count like constant, and it is space complexity is O of 1. So we satisfied all the condition, and yeah, that's the today's challenge. We will meet you tomorrow. Thank you.